Welcome to a new video on this tutorial on using Earth system model. So this is part 2. In part 2 you will learn how to search for Earth system model data. So these are basically, so there are different modeling groups that participated in CMIP6, and after they finish their simulation, they will upload their data on, for example, Earth System Grid Federation, on the CEDA archive, or like PRIMAVERA project. This is for the high resolution Earth system model. It's a special project for high resolution Earth system model. So in this part 2 of the tutorial, we will learn how to search for this data, how to download this data, and how to have a quick access and visualization of this data. In part 3 we will learn more details about how to handle this data and visualize and plot this data in details in part 3 and part 4 of this tutorial. Okay, so the outline of today's lesson is we will first have a tour in the Earth System Grid Federation. The aim of this tour is just so that you would become familiar when I talk about the directory structure template. You would know what exactly this is and what I'm talking about of CMIP6. If you don't know what is CMIP6, you can check the first video in part 1 where I introduce this general terms. You will know also in this video about the global attribute, description of CMIP6 and the file name template, and then we will do an example of how to search for ZOS data on Earth System Grid Federation. So ZOS, that is sea surface, that's the abbreviation for the standard name for sea surface height above GUID. And then we will learn how to browse this data and how to list on CEDA archive and how to browse this data on the PRIMAVERA project. Then I'll present some of useful link for topics that I covered. So we will start by doing a tour on the Earth System Grid Federation. Okay. So here is where you will find the CMIP6 data uploaded for the projects that finish their simulations, and will upload their outputs here, the data here. So let's do for example, if you don't know the variable name that you are interested in, you can see here the CF standard name, the description of this variable. So here we are interested in sea surface height. So we can browse here and see what is the available data for sea surface height. Okay, so sea surface. Okay, here we go. So we have here sea surface height above the GUID, and like you see here, you have 13,000, more than 13,000 of them, and that's huge amount of data to process. So let's see, let's refine our, let's see, let's search for this data, for example. And as we see here, we have more than 13,000 of them. So we can refine this data because we don't we are not interested in all of this data. So we can, for example, refine this data by the experiments that we are interested in. So you see a lot of these experiments are not of interest to us. They might be of for the general user, they might be interested for climate scientists and for model development. But for the general user, we would be generally interested in historical simulation with historical forcing. And for historical simulation, we will have two of them. We will have the historical simulation for the standard CMIP activity, and that experiment would be from 1850 to 2014. And it would be the other historical one, which would be even of more interest to us, is this one, the historical 1950. And this one is for the high resolution MIP, that is high resolution Earth system model, and that could be generally more useful for us. So click this one, and other ones that we could be interested in, but that would be later, is this SSP. These are the scenario MIP for the future simulation, future projection. So here, for example, you have SSP 1 to 5 with different, like this is like 1.19, 1.26, 2.45. And if you don't know what does SSP stand for, you can check the first presentation for detail about this future projection or future scenarios, future SSP scenario. But for now, let's limit our result to historical 1950. So if we click search, okay, now that's like we can display like 100 of them, for example. Okay, so now we have 50 of them, and that's like a more reasonable number of outputs to process for to answer our research or management question of interest. So here, like you see, this is the directory name, which I will explain to the in detail, and this has like a standard like format. So it starts by this by the MIP era. So here we are in MIP era CMIP6. Then it tells you what activity is here, and like if we this is the historical 1950, this is one of the experiment of the high resolution MIP. So if I check for activity, I'll expect to find like the high resolution MIP. Again, if you don't know what's a high resolution MIP, check the part 1 video number 1, and you will find more details about what's a high resolution MIP, about like this activity. Then you find here, this is the name of the modeling group, which is here's the institution ID. So these are like the different institution that has produced this that has produced this 50 different simulations. So this is the name of the institution INP, and this institution, it only has like one output, and this is the name of the model. And here H, like you expect this high resolution model, this is the name of the experiment. Here, this is the member ID, because for each experiment you could run an ensemble, like a different realization, it was or a different like initialization for this experiment. So you can have like an ensemble like of different realization, and this tells you the table IDs basically tell you what this data is. So the table ID, for example, here, this is O means ocean and monthly. So this means that like this data that I will find here, it's an ocean data. And I mean, this is expected because this is sea surface height, and it's a monthly average. And this is the name of the variable, which is ZOS, the name of the standard name of the sea surface height. And here, this tells you something about the grid. So this GR means that this is a regridded data. So according to the CMIP format or requirement, while like GN, this tells you this is a native grid. So this data is native grid data of the model. So regridded data, this means it's like a longitude, latitude coordinate. But if it's a native grid, this could be like, for example, like a 1D grid, like they store the output in 1D grid for to like save space or something that you need to regrid it to latitude or longitude, or it could be regridded like it could be like a longitude and latitude grid that is different, that has a format that's different than the standard like CMIP6 format. So here you can, so in part 3 you will learn about like how to like more like operation, how to do more operation of this data, like how to regrid this data or how to clip this data to an area that you are interested in, and so on and so forth. Okay, so this is a directory name. Now, if you, this is a list of the files. So this has two files. So this is tells you the file name, and see here it tells you the variable. This is the ZOS, the table ID. This is an ocean monthly data. This is the name of the model. This is the name of the experiment. This is the ensemble member. This is the grid. And here this is the time range, and this is not that time range of the experiment. This is that time range of how this modeling group stored this data of this this simulation. So here, like say they store their outputs like in two files. The first file is from 1950, January 1950 to 1999 December. That's like where their first file. The second file is from 2000 to the end of the simulation period, because this Historical simulation is from 1950 to December 2014. So you see this modeling group, for example, stored their, this modeling group stored their outputs like in 6 files. So I expect like for this 65-year, like a 10-year each, and then maybe the last year it will be like for 15 years period. Here, this is like 7 files, so I would expect this will be like a 10-year each. Like if we list here, just expect it from 1950 to the 1959 December, and then the second file 1960, 1970, 1980, and the last one, this will be like for a 5-year period from 2010 to 2014, for example. Here, like for example, if you see this is 65 file, like if I list this, I would expect that they are just, for each year they have 1 file. So here from 1950, there's just 1 file for 1950, another file for 1951, a third file for 1952, and so on and so forth. Let's see if there is a modeling group that just stored all their data in just 1 file. We have something like this. I think one of them did this. It was a huge. Oh, here. So you see here, for example, the NCAR, they just stored like all like this ZOS output just in 1 file. So if I clicked here, I would expect that the time range of this file, it will start from 1950 January and ends at 2014-12. So here, as expected, 1950 January 2014-12. Okay, so this is like a quick tour to the Earth System Grid Federation. Now we will learn about like this directory name and file name. We'll look at this in more details, make you familiar with it. Okay, so we go here. We did this tour. Okay, so the directory structure, as we see, we start by the MIP era, for example, the CMIP6, the activity. So here, for example, in this example, this is CMIP, so this is like the standard CMIP experiment. And the institution ID, this is the name of the modeling group. So here, this is the E3SM project. This is of DOE, Department of Energy in the USA Department of Energy. The source ID, this is their E3SM, their model version 1.0. The experiment ID, this is the historical because this is the CMIP6, the one with the standard resolution, so that's like the historical experiment. That's the member ID. I'll talk about this like RIPF in details. And then the table ID, that's the ocean monthly, it could be ocean daily, it could be atmospheric monthly, it could be atmospheric daily, it could be 3 hours. And then the variable, this is the name of the variable, and the grid. So here, this, for example, I tell you this is regridded data according to the CMIP requirements, so that should be something nice and easy to use. And then the version, this when they store this data, or like when they uploaded this data. So here again, like the activity ID, this is like, now we can see this in detail here. This could be like, for example, high resolution MIP. It could be the standard CMIP. It could be scenario MIP. This is when we start to look at this future like SSP1, SSP2, and land use MIP, and so on and so forth. And I talk about like these activities in the first presentation. So if you want to learn more about this activity, you can check the first presentation. The institution ID, this is the different modeling groups that are participating. The source ID, that's like the whatever model they are using. And because they could participate with more than one model for the same experiment. So for example, like this, the historical experiment, they generally conduct this experiment with standard resolution, like the standard resolution and the high resolution, to see the difference between when you make the same experiment with the standard resolution and the high resolution. So here, for example, EC Earth 3P, this is the high resolution, but they could also be doing this one with the standard resolution, like without this HR. And the experiment ID, that's like, for example, like the historical, this is SSP1, this is like a future projection. Here, this is SSP1 with a sub-experiment to it. So this is like SSB1, and they have this sub-experiment. I think this sub-experiment refer to if you have more desertification. So you can have like one experiment with sub-experiment with. Okay. The member ID, that composed of like two things. It composed of the experiment ID and the variant label. So here, for example, like the sub-experiment ID and the variant label. So here, for example, this is sub-experiment ID S1960, and this is the ensemble, like the variant label, like the ensemble member. So the variant label, it is like R here, this is the realization. So K here, this refers to the realization index, so they can have run the same experiment with different realization. The L here, this is like initialization index, so how they different initialization for the same experiment. P is the M here, this is like the physics index, like if they have like a different physics for the same experiment. And here this is like the forcing index, if they some like, so you can have like here R2, I1, like initialization 1, P1 and F1, and this would like these like this number here 2, 3, 4, it's not standard across modeling groups. So if you want to know what does I2 or I3 or I4 exactly mean, you have to refer to the manuscript where this model is described in order to see exactly what do they mean by R1 or like I2 or I3 and so on and so forth. Okay, and we go next to the table IDs. So the table IDs, as for example, could be, if you see here, this O means ocean monthly, it could be ocean daily, it could be atmospheric monthly, it could be Earth. This is for the land model, like this is E here stand for the land model, monthly, 3 hours, it could be like 3-hour data. Okay, the variable IDs, the variables that you are interested in. So here, for example, this is ZOS, sea surface height, this is water table depth, this is like precipitation and so on and so forth, whatever variable you are interested in. And this is a grid variable I talked about, like this is regridded data, this is a native grid, and the version like subdirectory where the data was written or published, like when the simulation was completed or published, something like this. The file name you see is like the same things, like repeat, except what will differ is the time range. So for example, here this is E3SM for their historical experiment. They have a 5-year data, so for every 5 years they restore their data, and you see this file, for example, is 10 megabyte. This, for example, for this model, it's a high resolution model. They store their data, like each file will only have 3 months of data, and you see this 3 months of data, 260 megabyte. 3 months, like here 5-year data, 10 megabyte, here's 3 months of data, 260, because there's a very high resolution model. Like the nominal resolution of this simulation, for example, I think is 10 kilometers, and that's why just like 3 months of ZOS, and this is just one variable, one output of this model. This is not all the output. This is just for this variable, the ZOS. You will find like each file is like 260 mega. You find this for this model group, for example, they stored everything just in one file, for like the whole experiment data from 1950 to 2014 in one file, and you see this file is 11 gigabyte, so it's huge file. And here, this is another example. This is the AWI model, and you see here, this is like even a different variation, because in these experiments they start counting from 0, while this one they store their data and they start counting from 1. So they start like the data store from 1981, for example, to 1990. So here they start counting from 1, and this is like they store their data 10 year by 10 year, and like a 10 year of data would be equal to 700 megabytes. So you see here the time range. This is not really standard. Like each one has the like more autonomy on like how they would like to store the each variable data. So now like we have learned about the directory structure and the file, like the directory template and the file name template. We can like do ZOS like search for this data. So we'll see, like now I will show you how to, so you can have like a clean start here. I will show you here how to first like search on this data here and then how to browse the data on the CEDA archive, for example, and how to list this data on the Primavera project. So here, like if we already know like the variable name that's like ZOS, okay? So here we can see, yeah, ZOS. Yeah, okay, so that's like 13,000 of them. We are not interested in the 13,000 of them. We are basically, let's see here, like, you know, we are interested, like we want to simulate some regional phenomena. So to generate regional phenomena, then we would be generally interested in more model with fine grid scale. So we can, here for the nominal resolution of the model, like you see here, 10 kilometer, 100 kilometer, 1000 kilometers. So that's very good, like a 10 kilometer nominal resolution. And maybe we'll be interested in the 25 kilometer. So we have like two of them. So if we like refine our search for like these two, like the 10 and 25 resolution for the ZOS data, and let's see what is available. So what is available is 82 of them. We can like here display all of them. So we have, so that's a more decent number of outputs that we can handle. Like we have 82 of them, but like these 82 of them, we are also not interested in all of them because we are interested basically in the historical simulation, and later on we will be interested in like this scenario in future projection, like in SP1, SP2, SP4 is not available here, but we have like SP5, so in the future we will be interested in like these things. But for now, we are only interested in the historical 1950s. This is for the high resolution MIP, and this is for the standard resolution MIP. And see here, like even for the standard resolution map, some modeling groups, they ran the standard resolution map with a high resolution model. Okay, so if we did this, like here, this is 20, this is 11, so we for these two resolution, let's see how many we will get. So we will like just as expected, like we get like 31. So now we have our search result in like 31 of them, 31 like model output. So for example, here this is a German model. So this basically tell you that this is the CMIP6 data. All of them would be like CMIP6 data. This tells you the activity, and here we expect like we have two activities. This is the CMIP6, the standard resolution run, and the high resolution MIP. So, and this is the name of the modeling group, the model. So here, this is like the medium resolution. So the medium resolution, it has to be like 25 kilometers. That's like very high for a medium resolution. And the grid would be native. So for example, the AWI model, this is native grid. This data will be stored like in a 1D array data, and you need to regrid this data so that you can like in latitude or longitude, or you need a special tool like a toolbox to be able to handle like this native grid data. Okay, so here like you see, this is realization number 3, this is realization number 2, this is realization number 1, this is realization number 4, this is realization number 5. The AW model here, again, we see they have like a high resolution MIP, and this is not the medium resolution, this is a high resolution run, and this is the name of the experiment, historical 1950. And for this one, I think they only have one of them. So, okay, so now you can see, like, if you want to learn about the institutions that are participating. So AWI, they have these 6 models. 5 of them is from the CMIP experiment, and 1 of them is from the high resolution MIP. EC Earth System Consortium, that's a European model, that's like has 3 of them. This one has like 9 of them, like 9 ensemble members. So for the same, like for 9 ensemble member, and so on and so forth. So this basically like an example for how to search for this data. You can also browse for this data. So you can go here for the CEDA archive, and let's say you are interested in the high resolution MIP. So you see like which group has uploaded their data. So you see these are the modeling groups that has already uploaded their data. Like this, the deadline of this CMIP simulation is end of this year, I guess, but many of the modeling group are like behind schedule because this is because IPCC 6 assessment report is like due next year, and this model are used for this report, but many of them are like currently behind the schedule, maybe for the corona or other reasons. So like still like more will be coming soon. More like you will see more modeling group. Like now we have like 16 of them, but more will be coming soon. So let's see. We are interested like this one, this European consortium model, so we can see what's available. So they have for the high resolution MIP. So they run this with the high resolution, and they run this with the standard resolution model. So like let's see the high resolution one. They have like a control experiment. They have the high resolution future and the high resolution SST future. These are like different name of the experiment. So here like this is the description of the experiment. And if you don't know what does this mean, the experiment ID, like you can check here, like for example, to see what does this experiment mean, or you can also check here. So if you go to experiment index, and like if you search here for like whatever, like if you want to know what is historical SST means, then you can read like that description, like what does this exactly mean. Okay, so we go here. So this is the name of the different experiments. This is the experiment we are interested in, the historical 1950s. This is from 1950 to 2014. And for this experiment, we see what is available. Okay, this is like 3 realization as we expected. So here, for example, this one, it has, if we like click for this one, so it has like this 3, like this 3 realizations we expect to get some. Okay, so this is 3 realization R1 and R1, R3 and R3, and this is for, what's the difference between, okay, okay, so they have like here, they have 2 realization for the high resolution one, and 1 realization for this one. Okay, here like you have 3 of them. You get an extra one here. Okay, so if you want to go like to this experiment, for example, like, oh, okay, so you see why you have this extra one, because maybe this one is not available for what we are looking for, which is ocean monthly data. So it could be like this other realization, it could be available for variable other than what we are looking for. But what we are looking for is this ocean monthly data. And the variable we are interested in. And so these are like for this ocean monthly, these are the available variable for this ocean monthly. So if you want to, and again, let's go here. If you Okay, this is the ocean monthly data. Okay, and this is a grid, the native grid. And the files, okay, so this is what are the available files. So this is for this version. This is the version date, and here, okay, so this is the available file. So you see, for this run, I would expect this would be like 65 of them, because the data here is stored like every year. So from 1950 to 2014, this will be like 65 of them. And here you can like click here to download a file, or you can extract a subset of this file if you want. So this is how you can browse this data on the CEDA archive to see what's available. If here you can also list like what is available for, like if you know what you're looking for, like if you have a variable. This is the Primavera project. This Primavera project is mainly for the high resolution Earth system model. It's an European project for the high resolution air system model, where this high resolution Earth system model will be used for have more wide use and applications. Okay, so this is the ZOS data, for example, the experiments, the historical, the MIP table, the ocean monthly, and then you can do like a filter. Then you get what are the available data for this selection you made, and the data size, and you can use the number of files, this is start and end date of the simulation. And so this like we get this data in like the available data for this high resolution experiment. Here, if you want to, this is a CF standard name table. Like if you want to more details, like for example, like if I'm searching for sea surface height, this is sea surface height above GeoID. If I want to know what does this exactly mean, so you can go here and let's see, go sea surface height. Okay, so you can like see here sea surface height above GeoID, and this will give you like a description for this variable. Same detail, like here you can find it also on the CEDA archive. So you'll find here, for example, sea surface height. Okay, so sea surface height. Okay, above GeoID. If you click here, you find like the same information like the CF data standard. Here I showed you, this is like the experiment. If you want to know like what does this experiment exactly mean, like what does historical SST pre-industrial O3, for example, what does this mean? So you can read here more description, and here you can find the same data on the Climate Research Program, like in a different format. So these are like these links, they are like provided in the description of the video below. So let's go back to the presentation now. So we did this, we did like the search for the ZOS data on the ESGF. We browsed it, we see how to browse this data on the CEDA archive, like the Center for Environmental Data Analysis. And we saw how to list like available ZOS data for the Primavera project. So the Primavera, this is process-based climate simulation, advances in high resolution modeling and European climate risk assessment. Okay, so we did like a quick query for the data and list the available data. Okay, these are like some of the useful like links. So here, this is one of the links to the Earth System Grid Federation, the CEDA archive, and the Primavera. This is like the standard name. If you want to see like the standard name, like the variable ID, for example, if you want to see more details, like what does sea surface height above GeoID mean, for example, you can check this link. This is the table ID. So again, if you want more details about like table ID, like if you see like MON, so you don't know what does this mean, so you can check there, and this will tell you this like stand for atmosphere, and MON, this is like a monthly. The experiment ID, here you can check for different experiment. If you are not sure what does historical 1950 means, and you can check it there, or any other experiment. And here, this is like, if you need more details about the content of this video, you can go to the CMIP6 guidance or for data user, and you will find like more details about the topics that are covered here. Okay, so now we finish this part, like how to do a data search. In the next part of the tutorial, like maybe one thing I didn't show is like how to download this data from the ESGF, like how to do a quick download. Maybe I'll show it next time. But in the next part of this tutorial, I will show like how to download this data if you want to have more control over it with Python. And this is also another objective of this tutorial, is to introduce the student to use Python, and also I will also cover MATLAB, like Python and MATLAB to download and analyze this data. So basically, like, there will be, in the next video I'll show how to install Python and how to use like Jupyter Notebook and Jupyter Lab, and then how to use Python to download like data of a single models, and how ensemble like different ensemble member of like one model, and how if you have like 80 of them, how to make like one script, and how to organize your workflow to handle like 80 or 90 or any number of them, which will be like useful for the next part of like how to process the data analysis. And then I will show like as you notice, like when I presented this video, maybe I didn't talk about it, that these videos, they have an extension of NC. It's like a NetCDF. So I will show you in 2.6, I will show you how to have like a quick access to this NetCDF data and quick visualization with Panoply. And then in 6.7, 6.8, and the rest of the part 2, I will show you how to access this data with Python and MATLAB, so you can have more control over this data, which you would need for like processing the output, like this data, and for like have more advanced visualization of this data, and then for the analysis of this data to study the research or management or engineering problems that you're interested in. Okay, so that's the end of this video. Yeah, thank you, and see you in the next video for how to install Python in your computer. Thank you very much.